Hello, I'm Kim Mueller,
And I'm Sharon Gorgie.
and we're here today to give you a short overview of how scientists use atmospheric measurements of carbon dioxide to study the Earth's changing carbon cycle.
Carbon dioxide is continually exchanged between the Earth's surface and the atmosphere through a number of processes. Most importantly, using photosynthesis, plants or other organisms take CO2 out of the atmosphere in order to grow and build biomass. Roughly balancing this photosynthetic uptake is the release of CO2 back to the atmosphere through the process of respiration, in which plants and animals burn stored carbon in order to live. In addition, the oceans take up and release large quantities of atmospheric CO2. More recently, the Earth's carbon cycle has become out of balance due to two processes associated with human activity, namely land use change, or the clearing of forests for agricultural use, and fossil fuel burning for energy production.
If we look at measurements of atmospheric CO2 that are taken in remote areas of the world, specifically in Hawaii and also in the South Pole, we can see that atmospheric concentrations of CO2 have been increasing steadily within the last century. The Hawaiian measurements in red also show more seasonal variability than those from the South Pole. This is because there's more land mass in the northern hemisphere, and so the natural uptake and release associated with vegetation activity during the growing season is more evident in these Hawaiian measurements.
Emissions from fossil fuels and deforestation have continued to rise in recent times. However, not all of this extra carbon has remained in the atmosphere. Roughly half has been removed by natural processes on the land and oceans, although the total amount removed every year is highly variable, as shown in green on this plot. Carbon scientists are working to understand more specifically where this extra uptake or carbon sink is occurring, what processes can explain the strength of the sinks in different locations, and how long we can expect the sinks to continue.
In addition to atmospheric measurements of CO2 from Hawaii and the South Pole, we have additional monitoring stations around the globe that can shed some light on these questions, specifically where the carbon sinks are located. From these measurements, we can say with some level of certainty that the majority of the land sink is located in the northern mid-latitudes. More recently, scientists have begun focusing their attention on pinpointing carbon sinks at smaller spatial scales, particularly for the North American continent.
An atmospheric transport model provides the key to tracing back variability in measured atmospheric CO2 concentrations to the total regional carbon exchange that must have occurred at the land surface. This project looks at 3 measurement locations in Wisconsin, Texas, and Maine, specifically at the air trajectories arriving at the towers, and at the sensitivities of measured concentrations to surface sources and sinks across the continent, both of which are derived using an atmospheric transport model. Such a visualization tool is important because it helps to show which areas of the continent are constrained by these measurements at what times, ultimately helping us to assess when and where we can best quantify North American carbon sinks.